All right, today we're doing a deep dive into something that's pretty foundational. It's really the technical backbone of modern long-distance communication.
Hmm.
We're looking at a specific piece of kit called the Thor Broadcast F-RF-TX-MN-2MW Optical Mini CATV RF transmitter.
It's a mouthful, but a really important device.
It is, and our mission today is pretty simple. We want to understand how this little box works as, critical infrastructure.
And why the technical details matter so much.
Exactly. Okay, let's unpack this.
And it's probably good to start with some context. This isn't, something you just pick up off a shelf.
Right, this isn't consumer gear.
Not at all. This is a core product from HDTV Supply, and it highlights their partnership with Thor Broadcast. We're really talking about professional, investment-grade hardware.
So let's get straight to it. What is this thing actually moving?
Its main job is transmitting CATV RF signals over long-distance optical fiber.
And that signal could be carrying pretty much anything, right? Analog TV, digital.
Exactly. Analog, digital formats like QAM or ATSC, even your telephone and general data.
Okay, so for listeners who might not have worked in, say, a cable head end, what are we really talking about with those acronyms? QAM, ATSC. How is that different from just standard internet data?
Yeah, that's a great question because that's the crucial layer here. CATV RF is, well, it's the traditional radio frequency signal for cable TV.
Okay.
But this device converts it to light to send it over fiber. QAM and ATSC are just the modern digital ways TV channels are encoded.
So this thing has to be a real multimedia utility player?
It does. It has to handle the old analog stuff right alongside these really dense digital formats. That's why stability is just everything.
And stability is key because the distances here are serious. The bandwidth is 45 to 1,000 millihertz, and it can push a signal from 5 kilometers all the way up to 30.
And to get that kind of range, that 30 kilometers, and keep the signal clean, you need some very specialized hardware inside.
Which gets us to the core tech.
It uses a high-performance DFB coaxial laser.
DFB, that's distributed feedback, right?
Exactly. And that tech is what ensures the laser sends out an extremely stable single wavelength of light.
And why is that so important over distance?
Because even a tiny, tiny shift in wavelength over that kind of distance can cause huge signal degradation. The DFB laser, it basically locks that wavelength down.
And it keeps it locked down with some onboard processing, too.
Yeah, it does. There's a built-in microcomputer and auto-monitoring system that's constantly checking on the operational status.
And that's not just a nice feature. It actually extends the life of the laser.
It does, which is a huge deal. It's also surprisingly efficient. It draws less than 8 watts, so it runs very cool.
Okay, so this brings us to what might be the single most crucial detail for anyone actually deploying this.
I think I know where you're going with this.
Here's where it gets really interesting. It's all about the connector.
Yes.
You have to use an SKPC connector, an angle-polished connector. So why is that tiny little angle so absolutely critical?
It's all about eliminating light reflections. It is required.
So like an echo, but with light.
That's a great way to put it. When light hits a flat connection, a tiny amount bounces right back into the laser.
And that's bad.
It's catastrophic for the signal. That back reflection destabilizes the whole transmission. It can cause a total system failure.
So if your existing fiber has flat connectors, like a standard SC or FCPC, you're stuck.
You're not stuck, but you can't ignore it. You must use what's called an optical jumper to convert that flat end to the SCPC you need. It is a tiny detail that makes all the difference.
That obsession with a perfect connection really explains why this is investment-grade stuff. It comes with a 2-year warranty, too.
So what does this all mean? Well, it means this device, the 2MW transmitter, is just one component.
Right. It's part of a whole ecosystem.
Exactly. You need a dedicated receiver on the other end, like the F-RF-TX-MN-2 to complete the link. And if you need more power, Thor makes 4mW, 8mW, even 32mW versions.
All at the same wavelength.
All of this 1310 nanometer wavelength, yes.
And that brings us to our final thought for you to chew on. This model operates at 1310 millimeter. But some of the related higher power units switch the wavelength to 1550 millimeter. So the question for you is this. How does that shift in the physical properties of the light actually change the performance characteristics, specifically signal attenuation and the potential transmission distance of the whole system? Go investigate the physics of fiber optics.